Hi guys, today we're going to create our first Kubernetes deployment. So let's do that now. So for Kubernetes deployment, I'm going to use AWS EKS today. You can use any other cloud service like Azure and GCP also, but I'm going to use AWS EKS for now. So there are some prerequisites. So prerequisites like first, obviously you need a AWS account. Then you have to install AWS CLI on your laptop. So you can install AWS CLI, then you can log into your AWS account using that CLI. So you can run AWS configure and you can add your secret and other things, and you can log into AWS account. So if you have any questions or any trouble while logging into the AWS via CLI, then you can check out my AWS CLI video also. Then you have to install kubectl to run kubectl commands and interact with the cluster. You need a kubectl tool, so install that. Then also I'm going to use EKS commands. So for that, you have to install EKSCTL also. That is a CLI for EKS. So all of these are prerequisites. So configure all of this, and if you face any issues while configuring these, you can add that in comment. I will help you on that also. So let's start. So first, what we need is a infrastructure. Infrastructure is nothing but a cluster. So we need a cluster first. We can create a cluster from the AWS management console also, but I'm going to use EKSCTL command. So let's create the cluster now using EKSCTL. I can copy paste the command, but I'm not going to do that. I'm going to type the whole command now. So first EKSCTL, that is the tool. Then I'm going to create the cluster. So create cluster. Then I have to give a name for this cluster. So hyphen hyphen name, that is the flag. Then the cluster name. I can give any name, like I will give my cluster or any name. Then in AWS, I have to give the region, which region I want to spin up this cluster. So I'm going to spin up this in Mumbai region. So AP South one. Then in cluster, I have to give a something called as node group. Node group means group of our nodes. Means nodes here are nothing but EC2 instances. So group of worker nodes, basically these are. So hyphen hyphen node group. Then node group name. Node group name can be my node group name. So give. Then I have to give a node type. Node type is nothing but EC2 instance type. That can be anything like t3 dot micro, t3 dot medium, something like that. So I'm going to use t3 dot medium. So hyphen hyphen node type t3 dot medium. Then the number of nodes I need. So hyphen hyphen nodes. I'm going to spin up two nodes now. So hyphen hyphen nodes two. And then for auto scaling, I can mention minimum and maximum number of nodes. So nodes hyphen min, I can set it to one. Then hyphen hyphen nodes max, that can be 3 or 4. So that is a maximum number of instances for auto scaling. Then I'm going to add one more flag, that is hyphen hyphen managed. Here managed means this node group will be managed by AWS. So the health check of this particular node group, everything will be managed by AWS. And if you remove this flag, then it will be the self-managed node group. That's it. Let's run this now. So it should create a cluster now. So it will take 10 to 15 minutes generally. So let's wait for that. It will create our both the plane, like control plane and data plane, that I've explained in Kubernetes architecture video. That is the previous video. You can check out that. So first it will create a control plane. You can see here it will create a control plane for my cluster. Then it will create a data plane like a node group and everything. It will create like a node group is nothing but the group of your EC2 instances. It will take 10 minutes. So let's wait for that now. So now the cluster is created. You can see that my cluster in the AP South 1 region is ready. So now I can run a command called as EKSCTL get cluster. You can see cluster is created. Name is my cluster and region is AP South 1, and it is created using EKSCTL. Also, you can check that cluster in your console also. So it took 10 to 15 minutes to create the cluster. That is because it create lot of resources. It create whole infrastructure. That's why it took that much time. So in backend, it uses CloudFormation templates. If I go to CloudFormation resource in AWS, I will get two CloudFormation templates are created. One is for my EKSCTL, my cluster for whole cluster, and another one is for my node group. That is for worker nodes. So if I open my cluster cloud formation template, and if I check resources here, here you can see these many resources are created. So to create all of these resources, it took 10 to 15 minutes. So it create NAT gateway, internet gateway, in backend it will create all of these resources. If I run that tkctl create cluster command, it will create all of these resources now. Then if I check one more stack, that is my ng, that is for node group. Here it has launch template and managed node group and node instance role. All of these resources it created. So if I go to EC2 now, it should create two nodes. So if I go to, because number of nodes we have mentioned two. So if I go to instances, here you can see there are two nodes are created. That is my ng node. So now the cluster is created. To interact with the cluster, generally we use kubectl command. So before using kubectl command, we have to configure that kubectl command to interact to have the access of my cluster. So to configure kubectl, I can run command aws eks, then hyphen region, that is ap south 1, ap south 1. Then I can I can update the config file, that is kubeconfig file, update hyphen kubeconfig, then the name of my cluster, that's hyphen name, then my cluster name is my cluster. So it will create a new entry in my kubeconfig file, and that will have the details of my cluster now. And if I see my this kubeconfig file now, cat, I will give this in double quotes, and this file path, if I paste this, here I should get the details of my new cluster, that is my cluster. So this new entry is added to my kubeconfig file. Now I can interact with the my cluster using kubectl. Now let's run kubectl command. So I will clear this. For example, I will run kubectl get nodes. So it will list all my nodes now, nodes of this particular cluster. I have not mentioned any cluster name here, but it lists the nodes of my cluster because in kubeconfig file I have had the entry of my cluster name. So now my cluster is ready and nodes are created. So next step will be the creating or deploying the application using kubectl. For that I have to create a YAML file for the deployment. So I'm going to create a file called as nginx deployment dot YAML file. Now I can copy paste the whole YAML file, but for a better understanding, I'm going to write the YAML file now in this particular video. So first in this deployment Kubernetes YAML file, I have four main contents here, like AKMS. A means API version, K means kind, M means metadata, and S means spec. So just remember that. So first is A means API version. No need to remember this, but if you write multiple YAML files, then you will get to know this, like API version, kind, metadata, and spec. So first is API version, apps slash v1. This is the API version. Then will be the kind. Kind is deployment here. So we are going to create a deployment resource here. So here kind nothing but what type of Kubernetes resource we are going to deploy. So here the resource will be the deployment. So Kubernetes deployment, there are other kind also like services and other things. So, but now I'm going to create a deployment. That's why kind will be the deployment. Then AKM, M means metadata. Metadata is nothing but to identify this particular resource, that is this particular deployment now. So metadata will be, I can give a name for this, like name. Then the this is the nginx deployment. That's why I'm going to give a name as nginx. Then last will be the spec. Spec means specifications. So specification. So in specification, we mention like how many number of pods we need. Those things we are going to mention here. So number of pods we are going to write replicas here. So replicas, I need two pods now. So replicas will be two. The selectors, as the name says, it helps us to select the specific pods for this particular deployment. So we select the pods based on the labels. So for that we have an entry called as match labels. Then we have to add a label using key value, like key will be the app, then value will be the engines. So we select the pods which has the label app engines for this particular deployment. So all the pods of this particular deployment will have the this particular label, that is app engines. So in spec we have the entry replicas, then the selector. So next entry will be the template. So template will be for the pod. This is pod template or pod blueprint. So each parts of this particular deployment will have the specification mentioned in this particular template. In this template, first entry will be the metadata. Here, this metadata is for whole deployment, but this metadata is for particular pod. All the specification mentioned inside template will be the pods, not for the deployment. So metadata, the metadata will be labels. I can have a label for each of the pod. So each pod should have this particular label, that is app engines, that I'm going to add here, app engines. So that is for metadata. Then have to add the spec for this all of this particular pods. So inside spec we generally mention the container specification. Pod is nothing but containers, right? So container specification I'm going to mention in this particular spec. Here spec first entry will be the containers. Containers. So inside the container first entry will be the name for the container. Name of the container, that is engines. Then container should have the image, right? So docker image, that is image. I'm going to use engines latest image, engines hyphen latest. So it will pull from the docker hub. This is the public image, so there is no issue for pulling this engines latest official image. So it will pull that image to create the engines container. The next will be the ports. Here I'm going to mention the container port. So container port I'm going to use is 80 port. So engines will run on 80 container port. Remember the extra tab here, that tab is not required, that is the index. So this is the YAML file. Let's save this now. Escape colon WQ. So YAML file is created. Now let's create a deployment. For that I have the command kubectl play. Then the hyphen f is the file for file name, and the file name will be engines deployment YAML. So now the deployment is created. So I can run kubectl get deployment. So kubectl get deployments. Then in replicas I have mentioned test2. That means two pods should be created. So let's check that. For that I can run kubectl get pods. So two pods are there, but status will be the error image pool. So there is some issue with my YAML file. Let's fix that first. Let me delete this deployment first. For that I can run kubectl delete deployment, then the deployment name, that is engines. The deployment is deleted now. Fix the my deployment YAML file. Here you can see in image I have mentioned engines hyphen latest. That is not the way, like I have to give the colon here. So engines colon latest. Here the image name and the tag will be the latest. Then this is the typo mistake. So let's save this file. Again create the deployment now. For that I can run kubectl apply hyphen f, then the file name, that is engines deployment file. Then kubectl get deployments. So deployment is created now. Again, if I want to see the pods now, kubectl get pods. Now you can see status is running. So now my deployment is created and my pods are running. But how to check whether my engines application is running or not? How to access my engines application from my browser? For that I have to expose this particular deployment. For that I have the command kubectl expose. So let's run expose command kubectl expose my deployment. Deployment is engines. Then the port hyphen port I want to expose it to 80 only, and the target port, that is the my container port, target port, that will be also 80 because container port is 80. Then the type of this is particular expose is nothing but a service that keeps a Kubernetes service and other things I am going to explain in next videos. So now it will be the external load balancer I am going to use. So type of this particular service is load balancer. Here you can see service engines is exposed. Now I can run kubectl get services. Here you can see engine service is created and I should be able to access this application using this particular URL, and the port will be 80 only, and there will be another port 32,460. This is the node port IP. So don't worry about this. I will explain this later, and also don't worry about this service and other things and load balancer. All of this I'm going to explain in next videos. But to expose this particular deployment, I can run kubectl expose command. Then I will get this particular external IP or external host name. Using this host name, I should be able to access my application from my browser. So it will take some 1 or 2 minutes to expose this particular URL. So wait for a couple of minutes, then you can copy and paste this in your browser, and you should be able to access the engine. Let's paste this URL and let's see whether it is accessible from my browser or not. It is accessible now. So using kubectl service, I can expose my deployment to internet also. So we successfully deployed my Nginx application, and we are able to access from browser also. So let's see how to delete this cluster now. To delete the cluster, I have the command called as eks delete cluster, then the hyphen name and the cluster name, that is I think my cluster, right? So my cluster. Then I can mention the region also. Region is AP South 1. So that's it. You can enter that. So it will start deleting my cluster. So it will take again 5-10 minutes to delete this cluster, because it have to delete all of those resources. So that's it for today. Today we learned how to create the cluster, then how to interact with that cluster using kubectl. Then we created a YAML file, and we successfully created a kubectl deployment. That is the end goal of this particular video. Then we also learned how to expose my deployment to the internet. So subscribe and check out other videos too, and keep learning.